Right, one of you has asked me to go through a couple of the questions from practice paper 1 from set 1. First one's question 10, which talks about a rotation of a point about the y-axis. Can I just make this point before I start it? In the textbook, in this bit you covered, there were the following results given on page 184. Rotation about the given axis, rotate about the x-axis, y-axis, z-axis, and reflection in a given plane. There is actually a section on transformations in 3D, so that's chapter 8, section 4, and that's all I'm going to do. And the other thing it says is these matrices will be given in the formula book. I'm going to try and find a way of sending you the formula book, because a few of you have asked just recently questions which I've just lifted answers straight out the formula book. So to rotate 45 degrees about the z-axis, about the y-axis, I'm going to use cos theta 0 sine theta 0 1 0 minus sine theta 0 cos theta, straight out of the formula book. When theta is 45 degrees, we're going to get 1 over root 2, 0, 0, 1, 0, 1 over root 2, minus 1 over root 2, 0, 1 over root 2. And the point we're rotating, so we take the 3 components of the coordinates and put it as a position vector, minus 13 root 2 upon 2, 10 minus 3 root 2 upon 2. Okay, what do I want to say about that? In terms of what we're doing here, if you imagine a set of axes, an x-axis, a y-axis and a z-axis, we've got a point which is minus x plus 10 minus z. We've got a point somewhere down here. So there's that axis there. We've got a point that way, and downwards. How can we rotate something about the y-axis? It's equivalent to taking that point and rotating it like that. Okay? We're rotating the whole thing about that axis. If we're rotating about that axis, the y-coordinate will stay the same. That's a circle of points where the y value is, for that point there, the y value is 10. Okay? When you go back to this form of it, if you look at this middle row here, when you multiply this column, you're going to get, the answer you're going to get is the middle term here, the j component of the position vector, or the y coordinates, the 2 zeros there, multiply the x and z bits will give 0, the 1 multiplies the y bit. This middle row is what means that the y coordinate is unchanged. Okay, but it's on the formula sheet, so I'm just having troubles attaching PDFs to emails, otherwise I'd have sent it to you. I'm sure you can download it from the AQA site, learn what's on the formula sheet. If you multiply that by minus 13 root 2 upon 2, it's a calculator paper, they all are. I'm just going to cancel the root 2's, so minus 13 over 2. That times that is minus 3 over 2. Minus 13 take 3 is minus 16, divided by 2, minus 8. 10. That times that is the minus 13 over 2. Multiplied by the 10 is 0. That times that is, sorry, the negative times negative is positive. That times that is minus 3 over 2. 13 take 10 is, 13 take 3 is 10. So that's 5. That's the starting point, using a result that's on the formula sheet. How can you rotate a vector? It's a point we're rotating. But you can rotate lines as well, but it's a point that's being rotated about that axis. Right, that means that the equation of L1 is R minus 8, 10, 5 plus mu lots of 2 minus 4 minus 3. Show that it intersects L2, which is 2x take 1 over 6, y take 11 over 6, minus z take 4 over 2. Right, whenever you solve, find intersections of two lines, or see whether two lines intersect, it's about substitution, one into the other, or equating something. I don't know if you've seen this way of doing it, but since I taught it, I can't remember I showed you this method, but it's all about consistency, as in can we show things work? That's the x, y, and z coordinates of all points on that line. The second line, that always has to equal that, always has to equal that. So what I'm going to do is slightly different here. I'm going to replace that x by that. I'm going to replace the y by that, and I'm going to replace z by that. And if putting those three things in this gives us consistency, then the lines intersect. Any inconsistency means they don't intersect. What on earth do I mean by that? So I've got two lots of minus 8 plus 2 mu over 6 take 1 equals 10 minus 4 mu take 11 over 6. Those two things have to be equal if it's on L2. Right, that's an equation in one unknown. Cancel the 6's, expand that. So minus 16 take 1 is minus 17. 4 mu take 17 is 10 take 11 is minus 1. So that would give us 8 mu is minus 1. So add 17, 16, mu is 2. So equating the x and y parts gives mu is 2. If mu is 2 makes all three bits equal, then we have consistency. So sub mu equals 2 in 2L2, I get 2 times 2 take 1 over 6 is 4 take 3 minus a half. I get 2 take 11. Right, mu is 2, right. I'm not substituting into there, I'm putting into this bit now here, aren't I? So if I put this 10 take 4 mu there, 10 take 4 mu take 11 over 6 equals, and if I put this here, minus 5 take 3 mu take 4 over 2. What do we get? We get, so 10 take 11 is minus 4 mu take 1 over 6. minus 5 takes, that's minus 9 plus 3 mu over 2. 6 multiplying by that, or cancel to get 3. So minus 4 mu take 1 is minus 27 plus 9 mu. Right. If I add 4 mu, 13 mu, add 27, 26, mu is 2. Right, what have I done here? Substituting into those bits gives me that value of mu. Substituting into those bits gives the same value of mu. There is consistency, therefore they intersect. Okay? Let's say I wasn't sure about that, or I wasn't convinced what I'd done. Right. Once I'd got the first value of mu is 2, I could go back into sub into L1. So we get R is minus 8 plus 2 mu, 4. 10 take 4 mu, 10 take 8. 5 take 3 mu, 5 take 6. So that's minus 4, minus 2, 2, 5 take 6, minus 1. Okay? Then sub minus 4, 2, minus 1 into L2 to check. So I want these three numbers to make this true. That equal to that equal to that. My mistake earlier was can't put mu into this. It's x, y, and z go into this. So 2 times minus 4 take 1 over 6 is minus 8. Minus 9 over 6 minus 3 over 2. Now I'm hoping when I put the other values in I get the same things. So y is 2. 2 take 11 over 6 is minus 9 over 6 minus 3 over 2. That's equal to that. Let's check it in the z. So the z value is minus 1. So we've got minus 1, so minus z, minus 1, take 4 over 2. 1 take 4 over 2 is minus 3 over 2. Excellent. It works. They intersect at minus 4, 2, minus 1 is one way of doing it, okay? The work solutions have a nice way of doing it as well, where we turn the Cartesian equation to the vector equation, but the question I was asked was about this result. How do we rotate about the y-axis? And it's in the book on that page, and it's on the formula sheet, okay? The other question I was asked was about question 12, the one with the drones and the shortest distance, which is a vector question about shortest distance to a line. My starting point when I do it will be a diagram. So we've got A, B, and a point off that line, which is C. But the key thing to note would be the drone starts above that point, 5 meters above that point. It starts 8 meters above that point, and the balloon is 197 meters above that point. So there is a drone flying in this direction. But remember, it's above these points and it is changing height, increasing in height. And we want to find this distance. We want to find that distance, the shortest distance there. So how am I going to do that? Okay then. What I'm going to start with is a diagram of what's happening. So we know the balloon is flying up from above A and above B to some point here. I'm going to call the point above B P. I'm going to say that the balloon is at a point Q. So that is 393, 304, 197. That's the point 438. And what we're looking for is this distance, that distance there. And I'm going to call the point on the drone's flight line that's closest to Q, I'm going to call R. Now, the way I'm going to do it is as follows. I'm going to say that we can find that direction vector, which I'm going to call B. And I'm going to get that from looking at how it travels from this point that direction vector I'm going to call B is the direction from where it starts to P. I can find that vector between P and Q, which means I can find that length, and because I know that vector and the direction vector there, I can find that angle. I am going to say that distance D, which is not a vector, it's a distance, is going to be that length multiplied by sine of that angle. How am I going to do that? Right. B, the direction of PR, is 438 take 005, which is 433. P to Q is that take that, that take that, that take that, which I reckon is 389, 301, 189. If I want to find that angle there, I'm going to dot these two things together and divide by their magnitudes. That's how we found cos theta. Okay, so what I'm going to do, I'm going to do PQ dotted with B, which is going to be, where's my calculator? That's going to be 389 times 4 plus 301 times 3 plus 189 times 3, 3026. To find cosine of that angle, I need the modulus of this one. So I'm going to square root 389 squared plus 301 squared plus 189 squared, which is 527. And I'm going to find the modulus of B, which should be easier. It's the square root of 16, 9 and 9, 25 square root of 34. I might keep that answer on the screen to do the following bit. So cosine theta is going to be, that was exact, it's going to be 3026 divided by that times that. So I'm going to do 3026 over the previous answer times root 34, which gives that, which gives sine theta, well, it gives theta to be shift cos ants is that, Therefore, D equals, I said it was going to be that length multiplied by sine of that angle. Shame, I should have kept that to more accurate. 527 multiplied by sine of that. 527 multiplied by sine of, previous answer, 91.3. Is one way of doing that question. Okay. Crucial things here. When you have the equation, when you're doing the shortest distance between a point and a line, draw your line. If it's in vector form, you've got a point on the line and the direction of the line. If it's in Cartesian form, you can turn it into the vector form, can't you? If you know the coordinates of the point you want to find the shortest distance from, then you can work out that vector and therefore that length. You can work out that angle by looking at the direction of this line and this actual vector, and then work it through. 7 marks. Yeah, I think that's worth 7 marks, isn't it? Right, I'm going to send that to, put that on YouTube, and then you can watch it.